Let's think about the definition. Multivariable system of equations. Example 6. How many variables do you see? Let's go back to the basics we did. When we have only variable x, we had only one axis. 0, 1, negative 1. When we had variable x and y, we had two axes, x and y. Then we also had like a equation, something like this. Then y was dependent, x is independent. Then when we had x, y, and z, we had three axes, z, x, y. Then we also draw like 3D shapes. Z equals like x squared plus y squared. It looks like paraboloid. I don't know how to draw. I should draw the cup. In this case, z was dependent and x and y were independent. Can you answer A, B, and C? A, what's the answer? 4. Very good. X, Y, Z, and 2. What is the number of dependent? How many? 2. Very good. Who are in the left side? So W and Y are dependent. That means independent is other two, X and Z. Now I'm going to draw a diagram for this one. Starts from W because I need to find the partial W. W has X, Y, and Z. So I'm going to draw a tree. X, Y, and Z. But Y can be written as Y equals X squared. That means Y is in terms of X too. Oh, not Z, X. Then when I look at this one, D, partial W with respect to X. That means for each one, I have to do respect to X. We call this one as a partial tree. Multivariable partial tree, partial multivariable tree diagram. Then now we are going to apply this to find partial W with respect to X. First, partial W with respect to the first variable X. Then X is in terms of X, so partial X respect to X. Then the second one, partial W to Y first. Partial W with respect to Y, but Y is in terms of X, so partial Y respect to X, then the green part, partial X with respect to X. So actually in the multivariable calculus, we usually have like a partial T, some other variable. The respect to T, then actually each X is written to T too. So we have like a less variable to learn the basic. So W, partial W with respect to Z times partial Z respect to X. So we call this one as a partial chain rule. It's applied. Now it's time to use the rule. So I'm going to evaluate. Partial W with respect to, easy one first. Denominator and numerator are the same, that means it's 1. So I'm going to ignore. So partial W with respect to X, look at only X part. Y becomes a constant, Z cube becomes a constant. So if I do the derivative, 2X plus Y. Then the second one, W2Y, so X squared and Z cube becomes now constant. So only XY derivative is X times Y with respect to X. That means derivative of X squared, so 2X times 1 and plus W2Z is 3Z squared times, there is a problem. nothing to get derivative for z in partial z with respect to x. That means 0. So if I simplify this one, I'm going to get 2x squared plus 2x plus y. Can I plug in x squared into the y? Then can I say, do I have to say 3x squared plus 2x? Not really in computer science class, because we are going to have a variable y, so we don't have to do it. But in math class, you may do. Question number 4. I probably will go back to the Algebra 1 class first. Linear regression. When we have lots of points, like a list 1, list 2, we plugged in x1, y1, x2, y2, x3, y3. Then when we hit linear regression, we got best fit line. Then we have y equals ax plus b with correlation. How much best fit? So when we had like r squared equals because 0.9997 something, then we think, oh, this is the best fit, perfect, because error range is 0.0002 something in this case. Wow, very small error. So we are going to think about how to find the error by hand. Why it's r squared? Because we want to find the positive values. To this graph, I'm going to draw x-axis and y-axis for my convenience. Then I'm going to pick one point. Let's just say this point is a point. That means ith point of this data set. Ith point will have x coordinate and y coordinate. This is a real data. Then I'm going to think about the best fit point. On the same vertical line, I'm going to say this point. So those two are at the same x coordinate, x, ith. This best fit is linear, so I'm going to say this is like ax plus b form, slope and y-intercept. So that means when I say this point, x coordinate is the same as point ith point, so xi, but y coordinate, I can use my equation, a times xi plus b. I'm going to find the error, that means I need to find the difference. Xi is the same, that means I can just check the difference between y. So I can say this is yi minus a xi plus b. So that's a difference. But sometimes yi will be the smaller than ax plus b. So I can give absolute value like a yi minus axi plus b. Wait a minute. We just did learn the partial. We reviewed partial. That means we probably will do the derivative. So I don't like the absolute because it's hard to derivative. So what we are going to do is square. Because we just need to know how far. So square is also okay. So finding distance. Now I have a question here. In this equation, what is known or given, what is not given, so we have to solve for. There are 4 variables, y-ith, a, x-ith, and b. So at the beginning, I said we are going to plug in x1, y1, x2, y2, x3, y3, so real data set, all the points into the calculator. That means, what is given? What is known? Yeah, coordinates, x's, yi's are given. Then what's not given? A and B. We need to solve for A and B. We have this experience before, like when we had like a point set. What is the plane equation? We did like a ax plus by plus cz, then blah, blah, blah. Then we plugged in the values. So we made the coefficient with variable a, b, c. Then we solved it for. So we are going to do like that. That means a and b are variables, so we want to make our equation into familiar to or convenient for A and B, not X and Y. Actually, y2 minus y1 square equals y1 minus y2 square. So I'm going to switch ax plus b and y, because I want a and b should be positive. So I'm going to rewrite this one as axi plus b minus yi square. I have to calculate error for all points. That means I'm going to get sum of all. So I will start from the first point to nth point when I have n points. Now I'm going to define error will be sum of y2 minus y1 square for all the points. So instead of xi, I'm going to use point ith x coordinate, point ith y coordinate. I'm going to just change a little bit. Point ith a times point ith x coordinate, that means axi plus b minus point ith y coordinate, then square. We need to find the minimized error. That means partial is 0. So slope is 0. So what we are going to do is partial e respect to x, not x, oopsie, a, because our variable is a, is 0. And also we are going to get partial e respect to b equals 0. To find the minimize, this is our goal, going toward there. So I'm going to calculate partial e respect to a and b, but a is more complicated, so I'm going to do b, then you're going to do a. So if I do partial e with respect to b, first in the sigma, when I do the derivative, I just do as a regular one, so 2 goes out. I'm going to have a sigma here. Then the whole thing becomes g of x as a composite function, the derivative times derivative of g of x. Nothing has b except 1, so b prime is 1, so multiply 1. I just use the chain rule of derivative. Now in the sigma, if there's a 2, 2 can go out, and sigma, then a times p sub ix plus b minus p sub iy. I can distribute sigma to each term. So I'm going to put 2 outside, then sigma a p sub ix plus sigma b plus sigma, not plus, minus p sub iy. Also, the constant a can go out, so 2 times a sigma p sub ix plus. There's no I, so I can just simplify as bn minus sigma p sub iy. Actually, our goal is making this one as 0. So when slope is 0, we are going to have minima or maxima. Then if I divide by 2, 2 is gone. So something equals 0. So somehow I would like to put a and b in one side and non-a and b to the other side. So I can rewrite this one as sigma piy, that means I add this one both sides, equals a times sigma pix plus bn. I can simplify in this way.